So is it true that A intersected with the empty set is just going to be the empty set? And the answer is, well, most likely. What does intersection mean? Intersection means we're looking at what is in common between two sets. In this case, any set A and the empty set. So if we have A containing some elements, right, doesn't matter how many, if it contains one or an infinite number of them, and then we have the empty set which contains nothing, what elements do they share in common? And the answer is none, right? This has to have no elements. This has some elements, so they share none. But you're then going to ask me, you're going to say, well, what if A was the empty set, right? What if A also was empty and then the empty set is empty? Well, here they share nothing, so the answer is still going to be the empty set. They share nothing together, and nothing is the empty set. But if A also had nothing in it, and the empty set has nothing in it, then what do they share? Well, they still share nothing, right? They both have nothing in common together. The fact that they both have no elements is the one thing they share together. Here, because they share nothing together, it is that nothing that they share. So I hope that sort of makes sense. More visually, this is sort of like saying, well, what does this set A have in common with nothing? And the answer is nothing. Everything that's not in A is going to be outside of A, so there's nothing in common with it. There's no intersection that we can just highlight here. So how are we going to prove that this is in fact going to be true? Well, first we need to recognize that this is in fact an equivalence, which means we have to show that A intersect with the empty set is a subset of the empty set, and we need to show the empty set is a subset of A intersect with the empty set. We have to show both of these are true in order to show that they are equal to each other. We have to show every element here that's shared is going to be here, and every element here that's shared is going to be here. So let's go ahead and do that. We first have to start with let, because this is a for all statement, because we are looking at any set A, which means that we want to suppose A. We're going to say let A be a set. Fantastic. We don't need to suppose the empty set. The empty set is something well defined. That's like saying let 1 be a number, right? It'd be the same as saying let the empty set be a set. That's silly, right? When you say 1, people know that's a number. When you say the empty set, people know it's a set. So we only need to define what A means. Okay, now let's start by proving our first case. Okay, so how are we going to prove that the intersection between A and the empty set is going to be a subset of the empty set? Well, we're going to want to start by saying something like A intersect with the empty set. That's where we're going to start. We're going to want to get to the fact that our goal is to get to the empty set. So let's create some representative element. We're going to say X has to be in here, right? And what do we find? Okay, well, for X to be in here, it means that X must be in A and X must be in the empty set. That's what it means for X to be in the intersection between the two. But we just notice here that there's a contradiction. This cannot be true. So that is false, which means there's a contradiction. So we say that because X cannot be in the empty set, there are no elements in A union the empty set, so it just becomes the empty set, right? That's the identity it has. Because it has no elements, by definition, it's the empty set. So let's write that down. I've already kind of put that into words. So we're going to actually write down here, this is all basically going to be a proof by contradiction. I'll put it down here. Contradiction proof. Okay, fantastic. So let's suppose an element. So we're going to say let X be an element of A intersect the empty set. Then we're going to want to break up what it means for that to be true. We're going to say then X is an element of A and X is an element of the empty set. Okay. But X cannot be an element of the empty set since the empty set does not contain any elements, making it so there are no elements in A intersection the empty set, so A intersection with the empty set is going to be a subset of the empty set. Because it has no elements, what else has no elements? Well, the empty set. Fantastic. We've proven our first case to be true. Now let's prove the second case. So our second case is to show the empty set is going to be a subset of A intersected with the empty set. So we're going to want to create another representative variable. We're going to say let y be an element of the empty set. Now this is immediately a contradiction. You cannot have an element in the empty set. So we're going to say that there's a contradiction here. Y cannot be in the empty set, so y cannot be in A intersect with the empty set, meaning A, well, I guess meaning, and that just goes here, right? Because there can't be any elements here, that means the only thing that could be here is the empty set, and the empty set is a subset of itself. So let's put that into words. Let's create our, this is going to be another proof by contradiction. So contradiction proof. Fantastic. So we're going to say let y be an element of the empty set, but this contradicts the fact that or we'll just say the fact that the empty set cannot have elements, so y is not an element of the empty set, meaning y is not an element of A I intersect with the empty set, so there are no elements in A intersect with the empty set, making A intersect with the empty set a subset, or sorry, making the empty set a subset. Oh, my writing's gotten very messy. Ooh, I'm erasing things. I need to fix this. There we go. My marker's dying too. Okay, I'm gonna have to replace one after this. Making the empty set a subset of A intersect with the empty set. So there we go. We've proven that both cases are true. Now we just need to write our concluding statement. So we say that since A intersect with the empty set is a subset of the empty set, and the empty set is a subset of A intersect with the empty set, then A intersect with the empty set is equal to the empty set. So there we go. We have now proven that this statement is in fact true.